Okay, let us continue. 3.3.2, supposedly 3.3.2, it is a dependent sample. 2. Okay, dependent sample. When we talk about dependent sample, let's say you have two dependent sample here and you take it related to each other. Okay, so you have sample 1, you have sample 2, and you calculate the mean x bar 1 and then the x bar 2. So this one is related to each other. So we call it as dependent sample. You will have a paired data. How you want to know that your data is dependent? Is a paired data. Your data must have similar sample size and both of the data came from the same object. Okay. So here you will have a capital D. Capital D means that it is a dependent sample. You have a paired data. So hypothesis testing for the dependent sample. So step number 1, formulate your hypothesis. Step 1, formulate your hypothesis. You must have H null and H1. So now on the left hand side here, you will have mu capital D. When we talk about the dependent sample, D is the dependent sample. Where your D here, you have to define. You have two data, right? So you have to define after minus before, or before minus after, or 1 minus 2, or 2 minus 1. It depends on the equation. Okay, on the right hand side here must be number. Okay, or it's either 0 or not. Sometimes for the dependent samples, they will put 0. Okay, so here at the center here will be the symbol. Okay, for example, if your hypothesis is two-tailed test, it will be mu D not equals to mu naught. So mu naught here is a value, right? So how about right tail test? Right tail, mu D greater than H1. Left tail test, mu D less than for H1. Right. So step number 2 is your test statistic. Okay, test statistic for dependent sample, we will use only one test statistic, which is t-test, where your sample size is less than 30. Okay, if you look at here, hypothesis testing for mu D, this one is for step number 2, your test statistic, we will use only this one. Okay, we will use only this one where sigma is not given and your sample size is less than 30. Use this formula only for dependent sample. For example 3.5, a new gadget is installed to air conditioner units in a factory to minimize the number of bacteria floating in the air. The number of bacteria in the air before and after the installation for a week is recorded in data as follows. So you have data before and after. Before means that before they install a new gadget, this is the data, number of bacteria. And after they install the new gadget to the aircon, this is the number of bacteria. So the question is it wise for the factory to install the new gadget? Okay, test at 5% level of significance. Is it wise for the factory management to install the new gadget? So from this question, I make my own claim. My objective is I want to minimize the number of bacteria. So if I want to minimize the number of bacteria, after I install the new gadget must be less than the number of bacteria before I install the new gadget. So I claim that it is wise for me to install the new gadget is if number of bacteria before is more than after. So baguslah untuk saya install new gadget untuk aircon tu kalau number of bacteria selepas pasang lagi sikit daripada sebelum pasang, ataupun sebelum pasang lagi banyak daripada selepas pasang. Okay, so this is my claim. I claim that it is wise to install the new gadget if number of bacteria before is more than after. So based on this claim, more than, okay, more than, before, more than, after. So you will have here more than. More than is H1. Okay. If your H1 is more than, H null is less than and equal. So the left hand side is here is mu capital D because this one is the dependent sample. So how about the right hand side? Okay, mu d. D is before, more than, after. Before mentioned first. So before minus after. Where your capital D is before minus after. So how about the mu naught here? Mu naught here is equals to 0. Right, so here is the mu naught equals to 0. So D is before minus after. So that's what we got here. Mu D greater than, less than, equals to 0. Mu D greater than 0. Where your D is before minus after. Okay, step number 2. Which formula you want to use? There's only one formula. This is the formula. So sigma square is unknown and is less than 30. So you have to find what is your x bar D, what is your SD. In order to find the x bar D and the SD, you need the new data D. For the new data D here is before minus after. So look at here. This one is before, this one is after. So before minus after, 10.1 minus 11.2, you will get 1.1. 11.6 minus 8.5, you get 3.1. 12.1 minus 8.4, you get 3.7, and so on. So this is your new data D. So from this new data D, you put into your calculator and you come out with the x bar D and the SD. Okay, after you got the x bar D and the SD, you substitute into the formula of the t-test. You will get the t-test value is 2.8281. Okay, done for step number 2. Step number 3, critical value. It is one tail or two tail. Look at here. Greater than. So it is a right tail. One tail. Alpha cannot be divided by 2. So alpha 0.05. T 0.05. Nu is equals to n minus 1. Okay. So you will get here 1.9432. So our test statistic is, so here is 1.9432 positive because of right tail. So our test statistic is 2.8281. It is located here at the rejection region. So you have to reject H null. So what will happen if you reject H null? So now you reject H null here. So you reject H null. So you accept this one. See, this is your claim. So you accept your claim. So at 5%, so at alpha 0.05, there is enough evidence to support the claim that it is wise to install the new gadget if number of bacteria before is more than after. So let's try to do the exercise. 3.3.2 number 1. Table below shows the average weekly losses of worker hours due to accident. Okay, this is the data of average weekly losses of worker hours. Okay, losses of worker hours in 10 industrial plants for before and after the installation of an elaborate safety program. So before they install the safety program, this is number of worker hours, and then after they install safety program, this is number of losses worker hour. Okay, number of losses worker hours. We talk about number of losses of worker hour. Okay, by assuming the data approximately normally distributed, test the hypothesis at 0.05. So alpha 0.05, either the safety program is effective or not. So we talk about effective now. So now you have to define what is effective. You define on yourself what is effective. Okay, I said that it is effective. I said that the safety program will be effective if number of losses of worker hour is less number of worker hour after is less than before. So safety program tu efektif lah kalau number of losers of worker hours tu lagi sikit daripada yang sebelum dia install safety program. Okay, jadinya safety program tu efektif lah. So this is my claim. I claim that the safety program will be effective if number of losers of worker hours after the safety program install is less than before. So this is my claim. So based on my claim, this one we will transform into the statistical notation. So step 1, H null H1. Okay, so H null H1 here will be the mu D because this one is a this one is a dependent sample. Okay. And next here will be number of less than. So less than here, greater than and equals to here. Okay, here will be 0, 0. Where the D is, which one comes first? After. So after minus before. Like that. Okay, it is effective if number of after less than before, where D is after minus before. Alright. Step number 1 done. Step number 2. Okay, step number 2, you have to find the D first. Okay, so find the D. D is equals to after minus before. Terbalik. 36 minus 45 is negative 9. 51 minus 57, negative 6. And then here is 13. Here is 6. Negative 2. 5. 5. Negative 2. 2. 6. So remember, after minus before, not before minus after. Okay, why? Because I mentioned after first. After is less than before. So after first, after minus before. Less than refer to this symbol. Okay, so step number 2, t-test. T-test is equals to, so look at the formula. T-test is equals to x bar D minus mu naught over SD over square root N. Okay, x bar D minus mu naught over SD over square root N. Okay, now I have my D data here. Substitute this D data into your calculator. You will get x bar D is equals to 1.8 and the SD is equals to 6.5625. Okay, mu naught equals to what? So mu naught is here. Mu naught equals to 0. N is equals to, how many data we have here? 10. So N is equals to 10. So now just substitute into the formula. 1.8 minus 0 over 6.5625 over square root 10. Okay, you will get the t-test. T-test is equals to 0.8674. Right, so next step, step number 3. Step number 3, one tail or two tail? One tail. Left or right? Left. So left tail. So left tail alpha is 0.05 and the nu is n minus 1. 10 minus 1 is 9. So T 0.05, nu is 9. Look at your stat table, you will get 1.8331. Okay, left tail, negative 1.8331. Right, so I'll put one page after. Okay, step 4. Reject or accept H null. So look at here. You want to reject or accept H null. This is your test statistic and this is your region. So where 0.8674 located at? So it is located at here. 0.8674. Rejection region or acceptance? Acceptance region. Okay, so we write down, since t-test is equals to 0.8674 is greater than t 0.059 negative 1.8331, you accept H null. Okay, you accept H null. So what will happen if you accept H null? Look at back here. Okay, now I accept H null. Accept H null. So I discard my H1. Oh, I potong my claim. I reject my claim. I accept H null. So I not support my claim. So you write down at alpha 0.05. There is not enough evidence to support claim that it is effective to install the safety program if number of losses of worker hour is less. Number of losses of worker hour after is less than before. So now because of the word effective, just now because of the word wise, so you have to make the claim on yourself. Okay, how about number 2? Okay, number 2, a manufacturer of automotive shock absorbers is interested in comparing the durability of its shock absorber with its competitor. One shock absorber from each manufacturer are installed on each rear wheels of said car. After the cars had been driven for 20,000 kilometers, the strength of each test shock absorber was measured and recorded. Result of the test shock are shown below. Okay, why this one is the dependent variable? Because they put the absorber, okay, both, one with the manufacturer, one with the competitor, with the same car. So the data come from the same object. So it is a dependent sample. Right? So this one is a D, capital D, dependent sample. So do the data present sufficient evidence to conclude that there is a difference? Okay, the keyword here is different in the mean strength of the two types of shock after 20,000 km of use. Use alpha 0.05. So now, no more wise, no more effective. The keyword here is different. Is there any different? So the word different refer to not equal. So not equal is H1. So how to formulate your hypothesis? So it is H null, H1. Mu capital D not equal 0, 0. So where your D is manufacturer minus competitor, because they mention the manufacturer first. Or you want to put competitor minus manufacturer, also can. Okay, because it is different. It is equal and unequal. Both is acceptable. You want to put manufacturer minus competitor, can. Competitor minus manufacturer is also can. So for this exercise, I want to put manufacturer minus competitor. So step number 1. Step number 2 here, your test statistic, your T test. So for now, you have to find the D first. My D is manufacturer minus competitor. So 8.9 minus 9.9, I will get negative 1. 10.7 minus 10.2, I will get 0.5, 0.4, 0.4, 0.5, negative 0.2. Okay, from this D, I will get the X bar D and the SD. So my X bar D is equals to 0.1 and my SD is equals to 0.6. Okay, mu naught equals to 0. So this one is your mu naught. And then you substitute all into the formula. T test is equal to 0.1 minus 0 over 0.6 over square root 6. So T test here I get 0.4082. Okay, and then the third step, step number 3, one tail or two tail. So this one is a two tail. Alpha divided by 2, so alpha is 0.05, so 0.05 divided by 2, 0.025. Nu is 6 minus 1, 5. T 0.025, Nu is 5. Look at your stat table, you will get 2.5706. And then you continue step number 4 and step number 5. Step number 4, I get accept H null. And step number 5, if accept H null, not support the claim. Okay, you can try on yourself here. So I'll guide you there. And say, number 3 here is a little bit different. Okay, so when you read the question, they did not give you the data now, right? A highway is constructed in Cerok. Cerok is a named place. The mean price of 20 acres of land in Cerok before the highway is constructed is 20,000 per acre with a standard deviation of 3,000. The mean price of the lands after the highway is constructed is 50,000 per acre with standard deviation 4,000 per acre. The mean and standard deviation for the difference of the land's price between the after and before the highway is constructed are 30,000 and 3,500 respectively. Test the hypothesis that alpha 0.01 that the highway increases the land price in Cerok by 35,000. Okay, when you read the question, there's a place named Cerok. This is a place. This Cerok, they want to build a highway. So, they said that this highway, before they built the highway, okay, the mean price of 20 acres, so N equals to 20, land in Cerok before the highway is constructed is, so X bar is equals to 20,000. And the standard deviation is 3,000. And then after they build the highway, they construct the highway with the same mean, because this is dependent, the same place, Cerok, so sample size must be the same. The X bar here is 50,000, where the S is 4,000. Okay, and then the next sentence, the mean and standard deviation for the different. Mean and standard deviation for the different means that the X bar D and the SD. X bar D is equals to 30,000 and the SD is equals to 3,500. So now you don't have to calculate the X bar D and the SD. X bar D and the SD is already given, where your D is equals to after minus before. Okay, the question is, test the hypothesis at alpha 0.01 that the highway increases the land price in Cerok by 35,000. So your hypothesis will be H null H1. Increases is greater than by 35,000. Here is mu capital D less than and equals 35,000. So what is the difference now? Now my mu naught is equals to 35,000. Okay, so this is step number 1. For step number 2, your T test is equals to X bar D minus mu naught over SD over square root N. So X bar D is 30,000 minus mu naught is 35,000 over SD 3,500 over square root N. 20. So you will get the t-test is equals to negative 6.3888. Right? So for step number 3, it is one tail or two tail? One tail. Right or left? Right. So it is a right tail. Oops. Positive. Okay, you can find on yourself step number 3, number 4, and number 5. Number 4, the decision is reject H null. Number 5, the conclusion is I reject my H null. So enough evidence support claim. Right, so try to do on yourself with this guidance. Okay, that's all for the 3.3.2 hypothesis testing dependent sample.